I think that if we want to actually learn something from this particular question, we should try to solve it abstractly. The question is asking for a ratio of two numbers, and statement 1 gives us the difference between those two numbers. So ask yourself, if I know the difference between two numbers, can I infer their ratio? For example, if you know that I'm 30 inches taller than my son, that's a difference. Can you infer whether I'm twice as tall as him, or 3 times as tall as him, or what percent taller I am? No, you don't have enough information. So statement 1 is not sufficient on its own, and we should eliminate the answer choices that claim that it is. So A and D are gone, and we're down to B, C, or E. Now statement 2 gives us one of the numbers. So if you know one of two numbers, can you infer the ratio of those two numbers? No, of course not. I don't know what the other number is. So statement 2 isn't sufficient on its own either, and we should eliminate B. Now if we combine these statements, we know one of the numbers from statement 2. We can infer the other number from statement 1 because we know the difference between them and we know which one is bigger. So if you visualize a number line, you know that the bigger number is 60 more than the smaller number, and you know exactly where the bigger number is on the number line. In this case, it's 240. Can you now infer their ratio? Yes, because you can infer what the smaller number is, and when you know exactly what two numbers are, of course you can find their ratio. So it turns out that when you combine these statements, you can answer the question, and therefore the correct answer is C. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.